Sorry for the delay, everyone. So I'm here to talk about JavaScript robotics. And I'm going to talk about two things in JavaScript robotics. First, I'm going to talk about one way that we've kind of advanced or evolved JavaScript robotics over the past couple of years. Then I'm going to talk about why I think you should be interested in JavaScript and hardware. So I first got exposed to JavaScript robotics, or NodeBots, at JSConf in 2012. Rick Waldron presented Johnny 5 for the first time. And I had tried playing with hardware in the past, doing the C and flashing firmware in it. I didn't really get into it because it just wasn't very fun. But I saw Johnny 5 and saw how easy it was to actually do the hardware and not have to worry about all the other stuff. And I got really excited. So I went to NodeBots Day in 2013 and I got to do hands-on work with Johnny 5 and saw how exceptionally easy it really was. And I got excited. And I decided, right there that I want to build a robot. And I decided to build a walking robot, which was kind of foolish because I discovered something early on. Walking is very hard. It is very hard. There's a couple challenges. The first one's obvious. The robot has to maintain its balance. There's two classes of robot gaits. There's static gaits and there's dynamic gaits. Most of these robots are using dynamic gaits. Static gaits are those gaits where the robot's center of gravity is always contained within a polygon defined by the feet of the robot. If the center of gravity falls outside that polygon defined by the feet, it's going to fall over. A static gate is kind of the opposite. I'm sorry, I got that backwards. A dynamic gate is kind of the opposite. At some point, the center of gravity is outside that polygon defined by the feet, and the robot is out of balance. And it's compensating by shifting its weight or having some kind of counterbalance, or maybe it's just catching itself with its other foot. By the way, these robots were built by some of the best roboticists on the planet with giant budgets. So this is not encouraging. I think there's just a couple more. All you have to do if you want to see that, just Google robots falling down. That's the video you'll get. I decided to go with the static gate because it was easier, obviously. And I also decided to build a hexapod because I thought with 6 legs, it would be easy to keep the robot in balance because you could always have 3 legs on the ground. But it was actually a little harder than that. The second problem, besides keeping it in balance, that I had to overcome involved managing all the servos. And we've got to talk a little bit about robot anatomy to get into that. This is a cross-section from one of the legs of this little robot up here. Each leg has 3 servos. There's a coxa servo that moves the whole leg assembly this way. And then there's a femur servo that moves it all this way, and a tibia servo that moves the last segment in and out. Also, the other important point to know about is the end effector. That's the foot of the robot. It's what comes in contact with the ground. Here's the same assembly from overhead, coxa, femur, tibia. And I thought that to make this robot walk, all I was going to have to do is put the end effector in contact with the ground and turn the coxa, and it would move forward. Well, it does, but it gives you a robot that looks drunk. When you just move the coxa, it describes a circle around the coxa's axis of rotation. What has to happen is we need to get all the joints working together. Otherwise, when you're doing these circles, and if you have more than one leg moving at a time, they're working against each other. If I had the 2 front legs moving, they would both be pushing in on the robot, and either it would stress my hardware, or the robot would slip and slide on the table and just look like a sloppy drunk. So to get it to move forward in a straight line, we've got to compensate for that circle that we create when we move just the coxa. As I'm turning the coxa, you have to bring the tibia in and out to keep it moving in a straight line parallel to the Y and Z axis. But as you move the tibia in and out, the end effector moves up and down. So to compensate for that, you've got to move the femur up and down to get it all moving in a perfectly straight line that's parallel to the direction that your robot is moving. So that's just 3 servos on one leg. There's 6 legs, so 18 servos. And I was thinking, if I'm going to make this thing walk, well, I've done animation on the web. I shoot for 30 frames per second. That's 540 instructions per second that I need to send to this robot. I didn't even know if it was possible. Fortunately, this guy, Rick Waldron, the inventor of Johnny 5, did a presentation at Empire.js in 2014. It was called Bits of NodeBots Next. And he was showing some of the new things that were possible with Johnny 5 Johnny 5, by the way, I'm making an assumption that everybody knows what Johnny 5 is. It's a JavaScript robotics library that runs under Node. It makes building things with hardware extremely easy. It's definitely something worth checking out. We'll talk about it a little more in a minute. But he was doing a presentation of some of the new possibilities, and he was demonstrating this robot. This is a quadruped. The legs on this robot are very similar to the legs on this robot. They have a coxa, femur, and a tibia. And he was using Johnny 5 at the state it was in at this time to create this animation, or to create this movement. Now he's got 12 servos, but he was using Johnny 5's built-in servo.2 method. And servo.2 moved at 100 frames per second. So he's got 1,200 frames per second, or 1,200 instructions per second being sent to his robot. So that let me know that what I wanted to do was absolutely possible. Now I'm going to replay this real quick. I'm going to try, if I can find my mouse. There it is. Notice he's got a little bit of the sloppy drunk going on with his robot. The feet are slipping on the table. That's totally understandable because he had to write instructions for every servo by hand. There's a timer on each servo that's firing a callback to move each servo at the right moment in time. That's a lot of work. It's kind of overwhelming. And I decided if I was going to do it, I was going to make it easier for anybody else. So created the animation class for Johnny 5. If you've ever worked in any 2D or 3D editing program, it could be Flash, Edge Animate, 3D Studio Max. When you're animating something, you've got a timeline generally down at the bottom. And you can put on that timeline the objects that you want to animate. Then along the timeline, you can set cue points. These are points in time where you'll be defining some value. And you can have keyframes. That's the value for one of the elements you're animating at one of those cue points. And then tweening. You don't have to set the value for every single frame. It'll calculate the values in between for you. And easing functions, which allow you to accelerate and decelerate movements over time. It gives it a much more natural, non-robotic feel. So we wanted to get all this stuff into Johnny 5, and we had to take this metaphor that we use in visual editors usually and do it in code. And this is how it's done. Tried to make it easy. That's one thing that Johnny 5 does incredibly well, is it makes hard things easy. So we wanted to keep that in play. So this is the code for doing a simple animation in Johnny 5. Require Johnny 5, we instantiate a new board. Instantiating a board in Johnny 5 is kind of a magical step. You don't have to know the address of the device you're trying to control. It just goes and looks out on your serial port, finds what it thinks is the device you're trying to control, and establishes communication with it. It takes a lot of the heavy lifting out of the early part. You don't have to worry about communicating over serial. It's all handled for you. It's very nice. The next two lines, where I'm setting var right and var left, I'm instantiating 2 servos in Johnny 5. That's 4 lines of code, and I can already control 2 devices out in the real world, 2 servos. I can set them to go to any degree value I want just by calling right.to 10, and it'll move to 10 degrees. So really easy to get up and running with Johnny 5. After that, I'm instantiating an animation. So the animation takes one parameter, and that's the devices that you want to animate. So I'm passing in my 2 legs, right and left. The last step is to enqueue what we call an animation segment. An animation segment is like a movie clip. It's a short, reusable piece of motion. So stand, sleep, those might be something I would use on my robot as an animation segment. The segment only has a few requirements. It needs a duration. This one's set to 5,000 milliseconds, so it's a 5-second animation. It needs cue points. Those are the points in time where I'll be setting values, and they're done as a percentage, 25%, 50%, so on. And then keyframes is the hardest part. That's a 2-dimensional array. The first dimension maps to the devices I want to animate, so that first row is for the right servo, the second row is for the left servo. And then I just pass in my values at the various cue points. So pretty easy to create an animation, but there's a problem. This is a walk animation. So, yeah, that's nuts. I mean, nobody in their right mind, except for me, and I might not be in my right mind, would do this. So we needed something better. Let me show you one of the things that can happen with it. This was when I first built this robot, and it doesn't even have all the legs yet, and I was just doing some testing for animation. And I left out one of my keyframes, and it hit divide by 0, and it sent my servos to, well, it sent my servos to 180. The value I got was infinity. But if the robot had been completely assembled, the servos would have crunched into each other. When I say crunch, I mean crunch, and it would have destroyed some of the hardware, costing me hundreds of dollars for one bug in that array. So I didn't want that to happen. That's a really bad thing. We need something less crazy. So this guy, Ronald Jaramillo, he's from Copenhagen. He stepped up and he created an application called Go Johnny Go. It gives us a GUI for doing animations in Johnny 5. Now bear with me, I'm going to launch an application here. Okay, that's actually not the one I want. There we go. All right, reload that. Yes. Okay, so this will be a little difficult, but I'm going to try. So Go Johnny Go is an Express app. I'm just running it in an iframe here so I can get it in the presentation. But you can define any number of projects, and I've got my hexapod. Within that, you can have segments that you define. So I'm going to do a JSConf demo here. If you've got targets, I've just got 3 servos in this example, so it's not overwhelming. I can go down into this, and let me get this turned on. All right, and rewound. It's going to drop to the floor real quick. There we go. All right, so if I want to see what this animation does, I'm going to hold it up so y'all can see it. I can hit play. If I can find play. Does that play? There we go. And it just raises the arm of the robot and puts it back down. Well, that's not very interesting. So I want to add a little to this animation. Let's take this one, move it up. Let's take this one, move it up. Take this one, move it up. Now if I want to play back, I can just come back to my first cue point. Hit play. So we've got a little wave. Really easy to create an animation, a nice GUI editor for controlling hardware. So once I'm done and I've decided that I like it, I can click export. Is that export? I can't see. And it gives me that animation segment object that I can just drop into my code, and I don't have to worry about missing a cue point or a keyframe. So great work by Ronald Jaramillo. He really made life better. So let me get back to speaker notes. All right. So what can we create with something like this? Let's take a look. Let me bring up my second demo. There we go. All right, let's see. Let's get it in the frame. It's a little hard to see. It's very hard to see. Let's try something. Yeah, let's try. Got it? There we go. All right, so let's see this in action. I'm gonna have to be very careful with this controller here. So let's try and wake it up. There we go. Let me get it all the way on the table. It is expensive. All right, so let's wake it up. So that's an animation segment there. I've explicitly set the value of each of the servos at 4 cue points in time to get the legs up and down, and I can have the robot sleep. Let's bring it back up. We want the robot to move forward. I'm using a leap motion controller here, by the way. That's how I'm manipulating it. We can see it walking forward, like I was talking about in our challenge. So it's a nice, smooth movement. We can move forward and we can move backward. There we go. Slightly different gait there. That one had 3 legs off the ground. The first one had 2 legs off the ground at a time. Now, turning. Turning has a lot of the same challenges as walking, only instead of describing a straight line, you're describing circles around a concentric point on the robot. So each end effector is actually describing a different circle, but still, animation can totally handle that. So that's animation in, whoa, that's a bug. This is animation in play. So let's put it back to sleep. Let me turn this over so I don't wake it up. So that's animation. Thank you for that nice applause. Now I'm going to tell you something that kind of sucks. There's a problem. We are having to explicitly tell every servo what to do. If every time I wanted to advance a slide, I had to tell my shoulder to go to 10 degrees and my elbow to go to 40 degrees and my wrist to go to 5 degrees and then hit the button, I wouldn't get much done and I certainly would go over on time. But if I have over the years learned to just reach out and touch something, and we want our robots to be able to do the same thing. So we need to be able to work in a 3D coordinate space, a global coordinate space. Instead of giving values for each joint, we want to give values in XYZ coordinates, right? It's much easier to reason about, and it's much easier to adapt as the environment changes. Animation handles tweening of 3D points, but we needed a way to position those end effectors. So I have another hero, and she's talking here today. We're so lucky. Raquel Velez. She did a presentation, I think it was 2014, no, this is 2013 at JSConf. And she debuted a module that she created called Vector. And Vector gives us a suite of tools for solving the equations that we need to solve to be able to position those end effectors. I'm not going to say any more about that because Raquel's here to present some of her work herself, and it's really neat, so stick around for that. But it gave me what I needed to be able to take the next step with this robot. We needed a way to be able to position the end effector, but we also needed a way to be able to define the chain itself. And that was a kind of a tricky problem to solve. But with the operators that Vector gave us and the formulas that we found, we were able to create a module called THARP. It allows you to define a chain of servos and segments, and pass in an end effector position, and it will position the end effector for you. So let's see how the code in that works. Again, kind of the ethos with Johnny 5 is make it easy, make it fun. So we wanted to make it easy. So we're doing something very hard in very few lines of code. We're creating a chain, a THARP chain, and we give it a chain type. And that's just the configuration of the leg on this particular robot. We give it an origin point. So the robot has an origin point, and the chain starts some distance from that origin point. We define our segments, how long the femur is, how long the tibia is. And then we give it the objects that we use to instantiate our actuators in Johnny 5. So this is just, if I was creating a new servo in Johnny 5, this is the kind of object I would pass in. That's all I have to do to create a chain. Now robots are even easier. I've got my chains defined. I'm going to create a new robot. It's a hexapod. THARP knows about hexapods. And I'm going to pass in my chain values. And they do have to go in a certain order, right one, left one, right two, left two, etc. But once I've got that done, I've got a robot that can position its end effectors in real time and respond to input from the real world. So I've got another demo here. Let me switch my app. This will be demo 3. There we go. All right. So, light crew again, thank you. So what I'm going to do is I'm going to wake this, I got to turn this over. I'm going to wake this robot up, I hope. Oh, there it goes. All right, so that was a lot like the segment you saw earlier. Let me try closing that again. All right, so that was a lot like the segment you saw earlier. But the difference is that I'm animating the end effectors by setting a 3D coordinate position. So I don't have to think about the angles of each foot. And that lets me do things like translate the robot's center along different axes. So I can have it move forward. I think I'm overtaxing my USB. So I hate to do this, but I need to disconnect the camera. So I'm not sure how well that's going to work, but we'll try. Sorry, y'all. I know it's hard to see. It's not my fault. Apple only puts 2 USB ports on their computer. All right. So we've got it up, and now I can translate what the robot is doing along the X, Y, and Z planes, but keep the end effectors in the same position because their value doesn't change. All that changes is the formula that I'm using to find their position. But I can also, beyond translate, I can do rotation. So I can rotate the, the roll, I can adjust the pitch, I can adjust the yaw of the robot. So I've got complete 3D control so that these end effectors can be positioned in real time. So what's having to happen is we're having to calculate the position of each servo, each angle, for all 18 servos in Java. This is all JavaScript, I hope that was assumed. In JavaScript, pass it through all the layers to get it down to the microcontroller, and we can still get about 50 frames per second of rendering on the robot. So that makes me very happy. We can also do things like, let's see if I can get this to, I cannot. Oh well, so you just have to be settled with that. All right, so let's shut that down. So what does that mean? That means we'll be able to tell the robot, instead of positioning all those servos, we want you to grab that thing over there, and here's where it is in 3D coordinate space. So the next steps that have to happen for us to do more things with JavaScript robotics like this is be able to map our environment at a greater distance than we currently can and in more detail than we currently can. And we need to be able to do wayfinding, like given that map of our environment, how do we get from point A to point B? There's modules for both of those things. They just haven't been incorporated into Johnny 5 or Tharp yet. So that was my adventure and some of the things that we built with this robot. It was a lot of fun. I learned an awful lot, but not everybody might be interested in robots. You might think, well, I'm a JavaScript developer, I do server, or I do client. Why should I care about hardware? Our quirky little language is showing up in a lot of new places. It started out in the browser, of course, but it's kind of erupting on the server. Node has done a really great job of growing the user base of JavaScript. But there are more things coming. There are things already out here, like the Raspberry Pi, which is a tiny little Linux computer that can run Node and Johnny 5. There's the Intel Edison, which can do both those things, but has Wi-Fi built in, and it's optimized for doing Internet of Things type stuff. There's a Tesla 2, which is coming out next month, which has all those things. It's completely open source, both hardware and software, and it's like $35. So pretty exciting piece of hardware there. But there's more coming. I have a strong suspicion that devices like this, the Electric Imp, will soon have JavaScript. So this Electric Imp is a pretty amazing little thing. It's got a microcontroller. It's the size of an SD card, by the way. It's got a microcontroller in there with a Wi-Fi chip. It's got some LEDs to let you know what the status is. It's got a light photoresistor, so you can like blink up your Wi-Fi credentials from your cell phone. It's really slick. The biggest problem with it is it uses a language called Squirrel. Are there any Squirrel experts in the room? Awesome. No? No? Okay. So, which is fine. I'm not saying Squirrel's a bad language. I have no idea, really. But not many people use it. The wonderful thing about JavaScript is there's so many of us using it, and there's such a great community, and just watch NPM explode. It's hard to keep up. Well, there's some projects underway for JavaScript. JSConf, V7, duct tape, there's just a few, to get a much smaller JavaScript engine that can be put on embeddable devices like the Electric Imp. These devices don't have nearly the RAM or the processor that we would need to run V8. They need something smaller. So these projects are moving along. JSConf is sponsored by Samsung, so there's some effort there. And they want to make it so that we can run JavaScript on microcontrollers, not just computers. And these are the microcontrollers that are going to be embedded in, well, thermostats already, toasters, refrigerators, all the things that they keep promising us are going to connect to the internet will be connecting to the internet. And I think there's a really good chance they're going to be able to run JavaScript. That means that we as JavaScript developers will have a much larger universe of companies and people demanding our skills on different platforms than we're accustomed to developing for. So I think the time that any of us might choose to spend working in hardware is time well spent. And I think doing it in Johnny 5 is a great way to go because it makes it so accessible and honestly fun to do things with hardware. Again, takes hard things and makes them easy. It assumes that it's in an environment that's connected by default. When I say connected, I mean to the internet as a whole. It runs on multiple devices. Johnny 5 works with things beyond JavaScript. It can talk to the electric imp now, but there has to be a squirrel component that it can talk to. So you've got a big community of stuff that you can work with. Speaking of community, the NodeBots community is really amazing. There's a lot of representatives here in South America and Central America. They are, to a person, they are helpful. They are extremely nice. There are no dumb questions. Just jump on the Johnny 5 Gitter or in GitHub and ask your questions. People will be very helpful. If you've ever thought about contributing to open source, but I know this was true for me. I was a little nervous. I was afraid. I didn't know if I was good enough, to be honest. If you've ever thought about contributing to open source, this is a great repo to get started on. Because not only do you have someone in Rick Waldron who knows JavaScript extremely well, but it's an extremely helpful group of people, and no one's going to make you feel bad. You're going to get support and encouragement. And honestly, I learned a lot building animation. It was time well spent. So I'm going to give you a quote from Brian Hughes, who's one of the core NodeBots contributors. He said, "NodeBots is one of the few areas in tech that is really focused more on the people than the tech." So again, I encourage you to check it out, not just for the fun, but for the future. So how am I on time? Good. Thank you for your time.